All right, ladies and gentlemen, welcome back from spring break. It's nice to see everybody here today. We're going to begin today with our very first lesson on geometry, which is 7.1. Today we're going to be talking about Pythagoras' theory, or Pythagoras' theorem. And I know many of you are probably saying, who the heck is Pythagoras? Well, Pythagoras, as it says here, is a Greek mathematician way back in the day, probably as old as your parents. And most importantly, as far as we're concerned today, is that he discovered an important rule for geometry, which I'm going to share with you. His rule is all about right triangles. Most of you hopefully know what a right triangle is. It's a triangle that has a right angle in it. If it's got a right angle in it, it usually has this little symbol in the corner. If it's got that little symbol, that means that you've got a 90-degree angle in the corner. It doesn't tell you anything about the other two angles, but it does tell you that this angle is 90 degrees. In all right triangles, they have two things in common. They all have a right angle, and they all have one side that's longer than the other. In this case, this one here. The longest side is always exactly across from where the right angle is. So there's the right angle. Right across from it is the hypotenuse, the longest side. As you can see in this diagram, I've labeled all three sides. Usually one side is referred to as side A, which is usually the smallest side. Side B is usually the middle length side. And side C is the hypotenuse. Again, represented by letters A, B, and C. Again, this is the 90-degree angle here. All right, the magic formula that Pythagoras came up with is this formula right here. That a squared plus b squared equals c squared. And what that means is if you take the small leg, the smallest side, and square it, which means multiply it by itself, then take the middle side, which is b, and multiply it by itself, which is squaring it, and add those two things together, and it's going to equal always the side C times itself. This formula is really useful so that if we have two sides that you know, you can find the third side of any right triangle. So here is a sample question where we've got the small side A, which is 5, the medium side, which is 12, and we don't know what the third side is. We're going to use Pythagoras' theory to see if we can find out what the missing side length is of this right triangle. That little symbol should be down here in the corner. All right, so we're going to take the formula, a squared plus b squared equals c squared, and I'm going to plug in the numbers that I know. 5 is going to go here, 5 squared. 12 is going to go here, 12 squared. And that equals c squared. C is the unknown value that we're trying to find. Now I'm going to do the math. 5 times 5 is 25. 12 times 12 is 144. And I'm going to add those together, and that's going to give me what c squared is. Luckily for us, we've done algebra already, so we know how to solve this. Basically, it's a 2- or 3-step algebra question. I'm going to add these two things together, which is 169, equals c squared. Josiah, stop giggling. Next, to find out what c is, I have to square root both sides. And square root this side, and I get c is the square root of 169, which is exactly 13. So I now have found that c is equal to 13. What's that, Carter? You want to see one more example? All right, let's try one more. Here we have 7 and 3, and we don't know side C. Thank you for asking that question, by the way. So I'm going to use the formula once again. A squared plus B squared equals C squared. And I'm going to plug in the numbers. 3 and 7 for A and B. That's 3 squared plus 7 squared equals C squared. Now I got to do the mathematics, or the math behind it. 3 squared is 3 times 3, which is 9. 7 squared is 7 times 7, which is 49. All that is equal to C squared. Again, C is the number that I don't know. Then I'm going to add the two things up, which is 9 and 49, which makes 58, is equal to C squared. Then I'm going to square root both sides because I got to work backwards to solve out, find out what C is, and C is going to be the square root of 58, which with your calculator is 7.6. 157731. I'm just going to round it off to 7.6. So that way my answer for this distance is 7.6. Now, it does work because 7.6 is got to be the longest side, and it is indeed longer than 3 and longer than 7. It must be bigger than 7. If you sometimes get an answer that is smaller than 7, that means something's gone wrong in your calculations. Your number always has to be bigger than both of the other two sides individually. What's that, Anna? Oh, yes, sure. We'll do a quick review. If you've given two sides and you're trying to find the biggest side, write the formula out. A squared plus B squared equals C squared. It rhymes. You could probably make a TikTok about this, I'm sure. Substitute the known quantities, so that's going to be 8 and 14. So that's 8 squared plus 14 squared equals C squared. And then just use the algebra to solve it, which means you're going to square it, do the math. That's 64. And 14 times 14, use your calculator if you need to, is 196. And all that equals C squared. Then add the two things together. Makes 260. And then to get your answer, just square root both sides. So you now have C is equal to the square root of 260, which is 16.1245, and I'm just going to round it off to 16.1 centimeters as the mystery side. Check your answer. Well, check and see if your answer is indeed bigger than the other sides. And yes, it's bigger than 14, and it's bigger than 8, so it does make sense. It's a logical answer. That's another sample which we don't need to do. What's that? Yes. Olivia, thank you for asking that question. What happens if you don't have the big side, or you're given the big side and you're looking for one of the smaller sides? So this is definitely possible. You're given the hypotenuse, which is this one, which is the biggest side, and you're given one of the legs, one of the smaller sides. So in this case, we're given the smallest side, which is side A, and we're given side C, and we're looking for B. We don't know what it is. So we're going to use the exact same equation. A squared plus B squared equals C squared. But now I'm going to plug in A and C into the equation. So my A is 7 squared. B is unknown. I'm going to leave it as B. And C I'm given as 18 squared. So again, I'm just putting in the numbers that I know into the equation. So I now have, when I do the math, 7 times 7, which is 49, plus B squared. I don't know what B is, so I'm going to leave it as B. and 18 squared, which is 18 times 18, which is 324. I now have an algebra question again that I can solve because we are all highly skilled in algebra. I'm going to have to subtract 49 from this side and this side. That's going to leave me with b squared is 324 minus 49, which is 275. Again, my final step is going to be to square root both sides, and that is b is the square root of 275, which with your calculator comes out as 16.583. 123 actually. I'm going to round that off to 16.6. So that is going to be my new answer, 16.6. And does it make sense? Yes. It's smaller than the hypotenuse, which is 18, and it's bigger than side A, which is 7. So it is in between. So it is a logical answer, and that should work. I could check it by plugging all three numbers back into the equation and making sure that when I did the math, it all equaled out. So once again, if you're given the hypotenuse and one of the sides, just plug it into your same equation. In this case, we're given C, which is the biggest side, and we're given B, which is the second biggest side, and we're missing tiny little a. Yes, it's like little Anisha is missing. Again, a squared is going to stay as is. B squared is 16 squared, and all that equals 21 squared. You are going to need your calculator for this, unless you're Johnson. Then you don't need your calculator at all. So 16 squared, type that into your handy dandy calculator, is 256, and 21 squared is 441. Subtract 251 from both sides. Sorry, 256. And you get a squared, if I didn't screw this up, is 185. And I will solve it finally by taking the square root of both sides, and I get a is the square root of 185, which is 13.60147. But I'm just going to leave it as 13.6. And there you have it. That concludes lesson number 1. Well done.